Yeah. Now I'm talking about multiples and submultiples. So these multiples, submultiples are using for expressing the physical quantity or expressing the units. We will use this multiples and submultiples. But explaining you have a question, right? The question is, sir, easily we can apply the units directly, right? So we can use the units directly. But the thing is, when a bigger unit, when a bigger value we have, when the bigger value you have, then how do you simply will explain? The simple way is giving the gateway of these multiples and submultiples. Okay, with this possible, it is easily we can explain that a bigger value, or with this possible we can say a small value in a simple manner. Understand? So now, so that first of all, here this multiples I will explain, later I will explain some multiples. Multiples nothing but 10 multiples. Here multiples indirectly nothing but 10 multiples. Here 10, if this is 10, this multiple name is called deca and represent with the letter D. Represent with the letter D. And one more we have 10 square. The 10 square, this is a 10 multiple. So this is called hecta. This is called hecta. Represent symbol is H. The symbol is what? H. The H representing that hecta. Next, 10 power 3. 10 power 3 means kilo. Kilo simply we will show with a K, small k. And next, 10 power directly, 10 power 6. 10 power 6 representing mega. Not mega star, it is simply mega. Mega star is a Chiranjeevi, right? But this is not Chiranjeevi, this is a mega, 10 power 6. So mega means we represent with capital M, isn't it? Next, 10 power, so after that 10 power 6, 10 power 9. If this mega star, then this is superstar. No, not superstar. This is 10 power 9 is a giga. 10 power 9 is what? Meaning is what? Giga. Giga simply represented with G. So similar way, after the 10 power 9, we have one more thing, that is 10 power 12. The 10 power 12 is called tera. Tera simply T. Tera simply T. So these are the multiples of 10. Generally, oftenly we use these multiples in our daily life along with units, isn't it? Now, so keep it in mind, better everyone write down. I hope I think this is not visible to you. This is not visible, so let me write here. 10 power 9. 10 power 9 is called giga. Is represented with the letter G. 10 power 12. The 10 power 12 represented with tera, represented with T. So this is the multiples of 10 and the names of these multiples and symbols of these multiples. Okay. Next, let me explain. Let us see examples on these multiples. Later we will go for submultiples. So better write down these multiples and submultiples. So here, now examples. How we are using, for example, let us take for length. I am measuring length. This is a length unit. How we are using these multiples, submultiples for the length. So you know, length generally we measure meter, centimeter, kilometer, right? Isn't it? Kilometer. So here, kilometer. So kilometer is actually, what is meant by this kilo? Kilo stands for already, I given, kilo stands for what? 10 power 3, 10 power 3, and this is a meter. So simply, so 10 power 3 meters is nothing but what? Kilometer. So 10 to say, I mean, pronouncing the 10 power 3 meters is very difficult, right? So calling as kilometer is very convenient way. Am I right? Yes, you are right. Calling the, I mean, explaining or expressing the 10 power 3 meter is very not convenient way, but kilometer is a convenient way, isn't it? So that these multiples here, 10 power 3 is a multiples of what? Meter. So here kilo stands for 10 power 3. So that is the meaning of the 1 kilometer. Similar way, this is a length. Let me take mass. Mass also, you know, mass. You know, mass means not that mass, not mama mass. This is mass. It is a quantity, substance. So mass means, mass generally we measure in grams, pounds as well as kilograms, right? But kilogram, look at the kilogram, kilogram. So here kilogram means this kilo is a multiple of 10, right? So what is this multiple of 10? 10 power 3 gram. So which means that 10 power 3 gram we will call as kilogram. So in that, that kilo representing the multiple, the value of multiple is 10 power 3. The 10 power 3 grams is called kilogram. Shortly we will call kilogram. So that way, the convenient, in a convenient manner expressing the unit, the multiples are helping you. You know, nowadays we are using the memory, right? So memory will measure in bytes, memory unit, memory. So you have pen drives and memory cards, discs, hard disk, or CD-ROMs. These all are the instrument which is storage devices. But the storage devices, it has a unit that is called memory unit. The memory unit is byte. You know, the memory unit is byte. So here the bytes we will measure. So let us take GB. So GB, what is this GB stands for? GB stands for 1 GB, 2 GB, 3 GB, such a way that we will explain the memory, right? So, right? It is it. On the memory cards, how much is the capacity of the memory card? We will generally use it to call 1 GB, 2 GB. What is the RAM of your mobile? 8 GB, 6 GB. Nowadays, 8 GB, more than 8 GB also we are having. What is the ROM storage capacity of the mobile? We will say 256 GB, 125 GB, 4 GB, 8 GB. This is the way that we are using the terms. But what is the GB meaning? GB means this G representing the multiple. But what is the value of G? G is nothing but giga. This is called gigabyte. This is called gigabyte. But the giga representing that, how much value? 10 power 9. So the 10 power 9 bytes is called 1 GB. Even your mobile data also measures in this way, right? 1 GB data completed, successfully completed 1 GB, recharge one more time. This is the way you see the messages, right? But in that, what is this GB stands for? GB stands for gigabyte, understand, children? So this is the way the multiples will use to easy way to convert units. We are using this, isn't it? So this is some examples for what? Multiples. Let me explain for what? No? Submultiples. Now I'll start this submultiples. So better, I think you are writing. I'm expecting you are writing. Yeah, you can write. So now let us discuss about submultiples. Submultiples. So what is this submultiples? The decimal points representing in terms of 10 multiples of 10 is nothing but submultiple. The decimal values representing as multiples of 10 is known as what? Submultiples. So first one is 10 power minus 1. So this is a decimal actually. 10 power minus 1 we will call as deci. So this is a symbol is D. Deci. 10 power minus means deci. So next similar way 10 power minus 2 is a centi. Centi, not sentiment. It is centi. Simply centi, not sentiment. Okay. It is a symbol is C. Centi symbol is C. Next 10 power 3. 10 power 3 milli. What is that? Milli. So not mulli, it is milli. It is what? Milli. Milli simply M. Next same way 10 power minus 6 is called micro. So symbol is mu. What is the symbol here? Mu. Similar way 10 power minus 9. This minus 9 is called nano. Not nano car, it is nano. Number is nano. Nano represent with small n. Nano represent with small n. Next similar way 10 power minus 2. 10 power minus 2. 10 power minus 2 is called nano completed, right? 10 power minus 2 is called terra opposite pico. So this is pico, P small p. So this is the way we'll explain the submultiples. Okay. So that is the decimal points expressing in terms of multiples, 10th multiples is known as submultiples. These are some important submultiples. Let me give some examples for this submultiples here. So can I take out? Yeah, I am taking out. So let me give examples here. So the examples, yeah, I am taking this examples. Now examples. Yes, first one is example for submultiples. Same, I will take mass or else length. Let me take length. Length, you know, generally we use it to term centimeter, right? Centimeter. What is this name? What is this term centimeter? In that centimeter, this centimeter is nothing but centi is representing that minus 2, isn't it? Minus 2, yeah. Centi representing that 10 power minus 2 and a meter. So here centimeter also nothing but 10 power minus 2 meter. So expressing this 10 power minus 2 is very difficult. So very simply way we will call it as centimeter. Understand? Next one more millimeter. What is this millimeter? So actually millimeter we represent as mm. The centimeter we represent as cm. And millimeter we represent as milli stands for 10 power minus 3 meter. Shortly we write as mm. Mm, not mmts, it is mm, not cm, not chief minister, it is centimeter. So this is the way we will use the submultiples to express the length units. Similar way, let us take mass. Mass units. This mass, so you know kilogram completed, right? So now let us take milligram. So here milli stands for what? 10 power 3. 10 power 3. And this gram. So shortly we will express this milligram as mg. Where you observe this mg, you observe this mg on the tablet covers. If you see, turn the tablet cover, you can see this kind of expression, milligrams. Similar way, even you will observe some other thing, microgram. So this microgram means micro is standing as 10 power 3, 10 power 6. This 10 power 6 grams. This symbol is mu g. This symbol is what? Mu g. So this is the way the multiples and submultiples will use to express the physical quantity. And this is also helping you to convert one system of unit to another system of unit. Understand? Because in the last class we have been discussing that system of units. So to change one system of any physical quantity, to change one system of unit to other system of unit, these are helping you. So I hope you have understood how to use multiples and submultiples. And one more thing, we have some other kind. The other kind is general practical units for mass, length, time. Also we will discuss some practical units for mass, time, length. Let me discuss here some practical units for length. First let me explain it about length. So in a various science, so let us discuss practical units for what? Practical units for what? Length. First one is, actually these are the practical units are using for daily life. So for the length, generally SI unit is what? SI unit of length is what? You know, SI unit of length, yes, it is meter. It is what? Meter. But this meter we will not use oftenly. Oftenly we will use the practical units. The practical units, first of all, kilometer. Kilometer, km. So here, kilometer is one of the practical unit of length. And next, micrometer. This is used to measure size of the cells, size of the biological cells. Okay, micrometers, which is nothing but micrometer, simply we represent with the mu m. This is known as micrometer. So here kilometer means 10 power 3 meter. Here micrometer means 10 power minus 6 meter. One more thing, we have angstrom. What is this? Angstrom. Angstrom also unit for length. So 1 angstrom equal to 10 power 10 meters. This is generally used to measure wavelength of the wavelength of the light current. For that we use this angstrom. Next, Fermi. So this is Fermi-meter. So Fermi, so F actually we will express as a small fm. Small fm is not that radio fm. This is not that kind. This is unit here. Fermi meter. Fm is Fermi meter. That Fermi meter is also expressed as 10 power minus 12 meters. So these are the some units, practical units for what? Length. So length practical units. So better write down. And one more also we have, so sorry, Fermi means 10 power 15, right? So 10 power 15. Next, one more we have, one more unit, that is light year. Light year. So that light year is nothing but light year, better write down, the distance traveled by the light in 1 year is known as light year. The distance traveled in 1 year is known as light year, shortly represented with Ly. Then 1 light year is equal to how many meters? So shortly, light year is also one of the practical unit of length. 1 light year equal to how many meters here? That is 9.5 into 10 power 12. 9.5 into 10 power 12 kilometers. Is these many kilometers we will call as what, light year. Where we use these light years then? Yeah, to measure the distance between planet to planet or star to star, galaxy to another galaxy. We will use this light year values. Understand? So this is some important practical units for what? Length. See, I hope you have understood this. Next, let us go for another time, that is mass units. Next one is, instead of length, now let us discuss about mass. Mass, practical unit of mass. So I am taking this. So here light year means the distance travelled by the light in 1 year is known as light year. In kilometers, the length is 9.5 into 10 power 12 kilometers. So now let us discuss the SI unit of mass. First, the SI unit. The SI unit of mass. The SI unit of mass is kg, kilogram. Kilogram is a SI unit. Understand? Now, when the kilogram is a SI unit, then what is the practical unit of this mass? So now 1 quintal. This 1 quintal is a practical unit, that is equal to 100 kg. 100 kilogram is equal to 1 quintal. Next, 1 ton. 1 ton is equal to 1000 kg, which is equal to 10 quintal. 10 quintal is equal to how much? 1 ton. So generally this you have been seen while calculating the paddy. When calculating the amount of the paddy, we use this quintal, 100 kg. Okay, rice bags. In the rice bags also you will observe this kind of things. Next, 1 pound. So Asian people have been used this 1 pound, that is 0.435 kg, approximate value 0.435 kg. This is 1 pound. Okay, so these are the some practical units for what? Mass. Next, let us go time practical units. Let us go for time practical units. I am taking here. So next thing is time practical units. Time, T-I-M-E, time. Yes, our time also clicking here. So quickly complete it. So time units, generally time units. SI unit of time is second. Yes, in a second you can write. So now let's see the practical unit here. Practical unit of time. The practical unit of time, SI unit is second. The practical unit of time is minute. minute. Here 1 minute equal to how many seconds? 60 seconds. So next hours. Hour is also 1 hour equal to how many seconds? 3600 seconds. Next days, or else day. Day is equal to how many hours? 24 hours. Approximately you will take as 24 hours. After day, month. Month is nothing but 30. Some months are 31 also. Approximately you can take 30 days. This is actually called lunar month. After that, one more we have shake. Shake also. Shake is nothing but 10 power 15 seconds. The 10 power 16 seconds time value will call as the shake. So this is some important time, practical units of time. I hope you have understood these multiples and some practical units of length, time and mass. Now children, we will go to do problems based on this. For that, you must open your material. The material is appears like this IIT Foundation, prompted IIT Foundation. So open this book, your IIT Foundation book. In that, please open here. So remaining you can read once these all. So once read and go to the multiples and submultiple. This is synopsis 4. Practice sheet. You can open practice sheet 4. In that practice sheet 4, first of all, question number 1. What is this question number 1? Symbol that represents kilo. Symbols that represent kilo. Kilo represent with we will represent with small. Kilo will represent with a small k. So the answer is for that is, I hope you got it what it is. So obviously the answer is second option. So next 10 power minus 2 is called. 10 power minus 2 is called 10 power minus 2. This 10 power minus 2 is called, deci. Centi or deci? Centi, not deci. So it is, what is the option then? So first option, yeah. 10 power minus 15. 10 power minus 15. 10 power minus 15 is called femto. Femtometer. Femto. Next, 1 ton is equal to how many kg? 1 ton. 1 ton. 1 ton. 1 ton means how many quintals? 10 quintals. Quintal equal to how many kgs? So totally 10 power 3 kg. So 10 power 3 kg we will call as 1 ton. So the option 4 is correct. 10 power minus 3 is represented with the prefix. Here prefix means the name of the submultiples. So here 10 power minus 3 represents, yes, you are right, it is a milli. 10 power minus 3 represent that, not milli here, not malli, it is milli. So milli. So next thing is the multiplication of factor. The multiplication factor used to represent micro is micro. Actually, micro represent with this. The symbol is this, and submultiple is 10 power minus 6. So the answer is what? 3. Light year is a unit for what? Light year is a unit for, it is a practical unit of distance. So answer is what? Distance. Light year equal to how many kilometers? How many meters they are asking, right? So very tough question they are given. 1 light year is equal to 9.5 into 10 power 12 kilometer. Convert this is in kilo means 10 power 3 meters. So finally 9.5 into 10 power 15 meters. So answer just become, so second option, right?
Yes.
Kilometer is how many times of meter? Kilometer is how many times of meter? Kilometer kada. Kilometer is equal, kilo stands for 10 power 3 meter. So which means that how many times here? 1000 times. Is representing that 1000 times. Yeah. So next exercise 1 you can go. So all you can do easily. So I hope you can solve these problems easily with this. So now I'll stop the session for now. In the next class we'll meet with another topic. Until then you can solve these all exercise problems. So if you have any questions you can ask when I come in the next class. So until then I'm signing off. Bye bye.